Making observations is fundamental to all science. A quantitative observation or measurement always consists of two parts, a number and a scale. Both parts must be present for the measurement to be meaningful. In this textbook, we will use measurements of mass, length, time, temperature, electric current, and the amount of a substance, among others. Scientists recognized long ago that standard systems of units had to be adopted if measurements were to be useful. If every scientist had a different set of units, complete chaos would result. Unfortunately, different standards were adopted in different parts of the world. The two major systems are the English system, used in the United States, and the metric system, used by most of the rest of the industrialized world. This duality causes a great deal of trouble. For example, parts as simple as bolts are not interchangeable between machines built using the two systems. As a result, the United States has begun to adopt the metric system. Most scientists in all countries have used the metric system for many years. In 1960, an international agreement set up a system of units called the International System, or the SI system. This system is based on the metric system and units derived from the metric system. The fundamental SI units are listed in Table 1.1. We will discuss how to manipulate these units later in this chapter. Because the fundamental units are not always convenient, expressing the mass and so on, prefixes are used to change the size of units. These are listed in Table 1.2. Some common objects and their measurements in SI units are listed in Table 1.3. One physical quantity that is very important in chemistry is volume, which is not a fundamental SI unit, but is derived from length. A cube that measures 1 meter on each edge is represented in Figure 1.5. This cube has a volume of 1 meter cubed. Recognizing that there are 110 decimeters in a meter, the volume of this cube is 1,000 decimeters. A cubic decimeter, that is commonly called a liter, which is a unit of volume slightly larger than a quart. As shown in Figure 1.5, 1,000 liters is contained in a cube with a volume of 1 cubic meter. Similarly, since 1 decimeter equals 10 centimeters, the liter can be divided into 1,000 cubes, each with a volume of 1 cubic centimeter. Thus, 1 liter contains 1,000 cubic centimeters, or 1,000 milliliters. Chemical laboratories work frequently requires measurement of the volumes of liquids. Several devices of the accurate determination of liquid volume are shown in Figure 1.6. An important point concerning measurement is the relationship between mass and weight. Although these terms are sometimes used interchangeably, they are not the same. Mass is a measurement of the resistance of an object to a change in its state of motion. Mass is measured by the force necessary to give an object a certain acceleration. On the Earth, we use the force that gravity exerts on an object to measure its mass. We call this force the object's weight. Since weight is a response of mass to gravity, it varies with the strength of the gravitational field. Therefore, your body mass is the same on the Earth and on the Moon, but your weight would be much less on the Moon than on the Earth because of the Moon's smaller gravitational field. Because weighing something on a chemical balance involves comparing the mass of that object to a standard mass, the terms weight and mass are sometimes used interchangeably, although this is incorrect. The number associated with a measurement is obtained using